Guys, I hope you all are good and doing well for the preparation of your A2 mathematics. Guys, this video is about the binomial expansion for A2 in a case when we have the form like 1 plus h whole raised to power n, where the condition that n must be less than 0 or in fraction of a rational number like a over b shouldn't equal to 0, right? So if n is a rational number or is negative integer, then we can apply the binomial series, and in the formula sheet its formula is written as 1 plus h whole raised to power n is equal to 1 plus n times h plus n into n minus 1 over 2 factorial h square plus each time you need to make one less from the power n and multiply it with the previous results like n minus 1 already we have written. Now make one more less, n minus 2. We have 1 2 3 terms, so divide by 3 factorial as 3 plus if you want to write more, already you have written till 3 terms, so make one more less. After n minus 2, it will be n minus 3. Now you have 1, 2, 3, 4 terms. So divided by 4 factorial and h power 4 and so on. This will give you the binomial series. And this is the series which is called geometric series and infinite geometric series. We call this infinite geometric series. We don't have an end point, we'll continue. The for this series condition for binomial series are, we can write conditions, yeah, are number one. Out of the, the function, first term must be one. First term must be one. And, it must be one. Like here, you can see the first term. This is the first term. First term, it must be one. And whatever be second term, we are not interested with it. It can be anything. But and the second condition says about n should be less than 0, mean negative or rational numbers. Rational number like in fraction with denominator should be equal to 0 and a b are integers. Right? These two conditions must be justified before applying this theorem, and the theorem is here. And I am going to highlight this one like this. Oh, wait a minute. Yes, this. This is a theorem that is will be given in the formula sheet as well. Only two conditions you need to keep in mind when to apply this. Whenever you have binomial, bi mean two terms expansion. The first in the expansion, the first term must be one because binomial, already defined. Bi mean two, nominal means terms. So out of the two terms, the first term must be one, and n must be a negative integer or a rational number. Then you can apply this formula over here, and let's solve few questions to justify what to do when there is one in the expansion of binomial series and when there is no, the first term is not one, how can we make it one? We will discuss the both cases. Okay, fine. Let's take an example. Example is simple. Okay, the simple example, that question can be asked: expand say 1 plus 3x whole raised to power minus 1 by 3 in ascending powers of x up to and including the term in x3, simplifying the coefficients. Okay, this is one of the question. Yes, here, as we know, the binomial series, that's what the formula I wrote it, it is a geometric series, geometric progression. Then we can say it's infinite geometric progression, is better to say, because we don't have its endpoint. But as in the question, it is given you are restricted to express the result in ascending power of x, in ascending powers of x, and how long you need to keep applying this rule up to the including terms of in x3 until we get x3. Okay, the first thing, let's start it. The first thing, we need to justify this with the formula I written above, and let me write it again here. 1 plus h whole raised to power n is 1 plus nh n n minus 1 over 2 factorial h square, as we need to move until x3. So n n minus 1 n minus 2 over 3 factorial h3 and so on, right? So this formula of the binomial series we are going to apply here. But what is the difference here in the question? The question is this, right? We will compare h is equal to what? 1 is with 1, h is represented by 3x, and n is what? Minus 1 by 3. And you can see here, as the first term is 1, that's true, h is replaced with 3x and n with minus 1 by 3. So we will see, we will get, let me change the color. We'll get 1 plus 3x whole raised to power minus 1 by 3. Replace in the formula 1 plus n is 1 minus 1 by 3, and h is what? 3x. Plus again minus 1 by 3, minus 1 by 3, minus 1. I'm applying this series here over 2 factorial, and x is what? 3x square. H is this, plus n n minus 1 n minus 2 over 3 factorial and 3x power 3, so on. As you are restricted in the question to show result including x3, so we'll stop where we get x3, like here. We will not write any more term after this x3. Now just simplify it because we have to find the coefficients. This is 1 plus 3, the question, x power minus 1 by 3. 1, 3, 3 cancel, simplifying will give you minus x, and here minus plus minus 1 by 3 minus 4 by 3 over 2 factorial is 2, and it will be 9x square. Same, minus 1 by 3 minus 4 by 3 and minus 7 by 3. 3 factorial will give you 6, and it will be 27x3, because 3x whole cube is 27x3, right? Further, we are not bounded to write the further terms because you are restricted to write up till x3. So x3 comes here. So simplified 1 minus x, it becomes plus 2x square. Once you simplify this whole expression, this whole will give you 2x square. You better can simplify it because 9 will cancel with 9 and 2 to the 4. Yeah, very right. And similarly, minus into minus plus into minus minus, we get minus 3 is 9 is 27 with 27, and 28 by 3 mean 2, 14 by 3, x 3. We can get this one. Okay, so this is the final answer, and as we can see, the result is in ascending power of x and including term x3, and we have simplified the coefficient. That's the final answer. I hope it is clear. Let's go for the another question. Okay guys, here's another question, that is expand 1 over square root 1 plus x in ascending powers of x up to and including the term in x3. Again, you are restricted to finish your expansion when you get x3 and simplifying the coefficients, right? So let's see how to solve this. Uh, 1 over root 1 plus x. First, bring it in numerator. You know the value of square root is 1 by 2. When the terms come up, it becomes minus 1 by 2. Now, as it justifying the conditions of binomial series, the first term is 1 and n is what? Less than 0 or a rational number. So both conditions are satisfying here. So we will apply the series, and again I'm telling you the series here. I'm going to write for you. It will be given in your formula sheet, so no need to worry about, but just you need to apply it in a proper way. And we have to finish till x3, so first four terms will lead me with h3. 1 plus nh plus n minus 1 over 2 factorial s square plus n minus 1 n minus 2 over 3 factorial and h cube and so on. As here you can see, we are restricted to go with x3, so where h3 will come, we will stop it. So this is the rule, whatever you will find it in your formula sheet. Now just compare the value here. Here first term is 1, true. H is what? X. Here we can write h is with x, and what is n? N is equal to minus 1 by 2. Now replace here. The value is simple substitution method. 1 plus x whole power minus 1 by 2. 1 plus n is minus 1 by 2. H is x minus 1 by 2 times minus 1 by 2 minus 1 over 2 factorial. H is what? X square plus n is minus 1 by 2 minus 1 by 2 minus 1 minus 1 by 2 minus 2 over 3 factorial and x power 3 and so on. Again, in the question you are restricted to finish up till the term x3, so we will stop here. We will not do any more expansion of the series. So now simplify the coefficient 1. This comes me x by 2, and this will be minus 1 by 2 and minus 3 by 2 over 2 factorial mean 2 and x square plus again minus 1 by 2, and this give me minus 3 by 2. Okay, let it be in fraction, no need to write in decimal. Minus 5 by 2 over 3 factorial is 6 and x3. Further simplification, 1 minus x by 2 minus minus plus 3 by 2 to the 4 to the 8 x square and plus minus minus time minus minus into minus plus plus minus minus, and we can see 3 to the 6, it can be simplified to 2 to the 4 to the 8 to 16 and 5 by 16 x3. That will be the final result for this expansion up till x3. I hope it's clear. Let's do another question. Yes, guys, here goes another question in which we will discuss the part B as well. The question is expand 1 over 2 plus x power 3 in ascending powers of x up to and including term in x square, simplifying the coefficients. The first part is as like we did before, but only here the change is that the first term is not 1, which is the basic condition of binomial expansion for A2. So you need to make it 1 how? Like see, its question is like this, which need to expand. First bring this in numerator so that justifying the conditions become minus 3. Here the n is negative is true, but first term is not 1. So how can we make it 1? Taking common 2 from the terms, we can write 1 plus x by 2 and whole raised to power, let me use this one, 4 raised to power minus 3, right? What I did, I just took 2 with the power out of the bracket, and inside the bracket I divided each term with 2 to get this one. Now further, this can be written as 2 power minus 3 and 1 plus x by 2 whole power minus 3. You saw here we made the first term 1. That was a basic condition to apply the binomial series. So we made it first condition satisfied, and the second, the n is as negative, and it means now we can apply the binomial series. So 2 power minus 3 can be written as 1 by 8 and 1 plus x by 2 whole power minus 3. So we just need to simplify any expansion will be taken with this format only. So we'll write 1 by 8, and here I'm going to write a square bracket. The expansion, the formula, okay, for again I need to write for you. In short, 1 plus h whole power n is what? 1 plus nh plus n into n minus 1 over 2 factorial h square, because you are restricted to go with square term. So here further no need to expand it. This formula is will be applied here. Only the difference is you can write here h is what? X by 2, and n is what? Minus 3. Replace it. I will expand it 1 by 8 times 1 plus x by 2 power minus 3 in this formula, 1 by 8 bracket, because on expansion you done with the binomial terms with the power negative. So 1 plus n is minus 3, h is what? X by 2 plus n minus 1 over 2 factorials times h square, and so on. But as you're restricted for x square, so it will come here. So we write 1 by 8 as it is, 1 minus 3 x by 2, and you simplify this minus 3 and minus 4, and it becomes plus 12, and 4 is 4 3 3 by 2, it will be plus 3 by 2. You can do the simplification as your own task, and this will be the expansion of this. And further, as it was the expansion of what? 2 power, you can write 2 plus x power minus 3, right? So 1 by 8 multiply inside becomes minus 3x by 16 plus again 3x square, 12 4 3s are, yes, x square by 16, and so on. There's no need to so on. This is the final answer after doing this simplification. The part A has done. Now for the part B, as is given, find the range of values of x for which the this one is a function for which the function, this one original function, is valid. So whenever it's one marks question going to be attached somehow in in some papers. So whenever this kind of question to be asked, so only what to do for the B part, the term what you are going to expand by the series. That is, it means if you have h, modulus of h must be less than 1 to check the validity. If it is, it is given, and here you can find the range of values. So here what is x? It was x by 2 modulus less than 1. So we can write x mod is less than 2 multiplied on the other side becomes 2. Therefore, either this is the range of values, or you can write by the definition of modulus function, my range of value will be this, x values will be like this in between minus 2 and 2, which is the required range of values of x for which the function that was 1 over 2 plus x power 3 is valid. This can be asked for one marks question. For this, again, I'm telling you, just keep this rule in mind. The modulus of h from the series must be less than 1. This justifying the validity and the range of value for which it is valid. I hope it is clear. Let's do another question to practice on. Okay, fine, guys. Now I'm assigning you few practice questions to work on. First, understand the question. The form is the each part consists of each question consists of two parts. Like the first part, you need to expand the following function f of x. Like here, f of x is first part like this, 1 over 1 minus cx square. If you take the first part, you have to find the expansion with the standing power of x up to the term including x cube. This is 4 mark question, and same for the same question you need to solve the b part to find the range of values of x for which the function is valid. As I explained you, the modulus of h must be less than 1. You need to apply this property and get the values of x to understand it, right? After finishing this first part, do the second one, the same AB, and the third one, the same AB, right? And this is your task to complete on. Okay, good luck. See you in the next video.